All right, last video for the unit. We're going to do number 28 together. So go ahead and write the givens down while you pause, and then pick back up with me when you're done. All right, so we have our givens down, and we mark in the one thing we know for sure, that AB is congruent to CD, or to DC. Now again, we see we have two triangles here. This looks like a bow tie proof. But looking at what we're trying to prove, that's something new. We're trying to prove that AB is parallel to CD. So we're trying to prove that this line here is parallel to that line there. All right, we talked about this earlier. Whenever you see parallel lines in a proof, so whenever you see that parallel line symbol, the key to figuring that out, or the key to using that rule, is to look for congruent angles. So that parallel line should take us back to this parallel lines cut by a transversal idea. So basically, if we can find some alternate interior angles, or some alternate exterior angles, or some corresponding angles that are congruent, it will make the lines parallel. So it will lock those lines in to being parallel. So if we look at AB right there and CD right there, those are the lines that we want to make parallel, that we want to prove are parallel. And if you think about this as our transversal, so if we kind of look at this picture and forget the triangles for a second, if we just look at them as parallel lines cut by a transversal, hopefully, if we remember back to the beginning of the year, we see that this angle here and that angle there are alternate interior angles. So if we kind of work backwards a little bit, if we want to prove these lines are parallel, we need to prove that angle A and angle D are congruent. All right, to prove that angle A and angle D are congruent. In order to do that, we can work back one more step, and I'll get these lines out of the way. So in order to prove that angle A and angle D are congruent, we can just go back to what we were doing literally this entire unit and proving that this triangle is congruent to that triangle. So that becomes our goal. So if we can simply prove that the triangles are congruent, that will mean that angle A and angle D are congruent because of CP/CTC. And if those angles are congruent, then that will mean that the lines are parallel because the alternate interior angles are congruent. So it's a whole chain of events here. Basically, if you see this on a test or on a Regents or on the quiz at the end of class today, if you have no idea what else to do, just find some triangles and try to prove that those triangles are congruent. All right, so we have one piece right off the bat. Let's look at the givens first. First given, they tell you that AD is perpendicular to BC. So AD right there is perpendicular to BC. So this is kind of a new rule for us. This is a new thing. We're used to just seeing these as vertical angles. They actually gave us a little more in this case. They said that those lines are perpendicular. And we know perpendicular lines make those angles right angles. So that's where we can start. So naming our angles very carefully. I'm going to say angle AEB angle AEB and angle CED are right angles. And we know that because perpendicular lines make right angles. All right, so AEB and CED are right angles because perpendicular lines make right angles. And the next step we know that always comes after that, we can say that those right angles are congruent. So we'll say angle AEB angle AEB is congruent to angle CED because all right angles, and sorry my pen's giving me a little trouble, all right angles are congruent. So there's the second piece of our puzzle. We now have two pieces of this triangle congruent. So all we need is one more to get to that kind of chain reaction goal at the end. So looking at our picture, we have the right angle, we have AB congruent to CD. Now our other given, we use that one, our other given's right here. BC bisects AD. So BC bisects AD. That means AD is the one being cut in half. So that tells us, since AD is being bisected, it tells us that AE and DE are congruent. And that's the next thing we can write. So we all know what a segment bisector does. In this particular example, that tells us that AE is congruent to ED because segment bisectors cut a segment in half. So we did the hard part. Our triangles are now congruent. We have three pieces that match up. So looking at it very carefully, this is actually an SSA or ASS situation, which we know we can't have. But we do have our bonus rule. We can call this an HL congruency. So going back down, our last step to prove the triangle is congruent, we now know triangle AEB is congruent to triangle CED because of the right triangle HL congruency. Alright, so that opens up all the CP/CTC rules to us. Now remember what we said earlier. Since these two triangles are now congruent, it proves for a fact that angle A and angle D are congruent. And since angle A and angle D are congruent, that means that these lines have to be parallel because these alternate interior angles are congruent. So those last two steps are tough, but at the very least, we should all be able to get those triangles set up to be congruent at this point. So now the next thing we know, since these triangles are congruent, like I said, we can now say that angle A is congruent to angle D because corresponding parts of congruent triangles are congruent. And to finish it up, because those angles are congruent, the relationship between them are alternate interior. So that proves, because the alternate interior angles are congruent, that segment AB must be parallel to segment CD. And the reason for that is lines are parallel. Lines are parallel if and only if alternate interior angles are congruent. So those last two steps, we haven't looked at one like that in a while, but it all is based off finding those congruent pairs of triangles. All right, so good job. I would make sure you look at this one carefully for your quiz today, and call me over if you have any questions.